task to be performed. Okay, and what is the input and what is the output for each task. Okay, the next one is, do you have, okay, is that activity have any pre or post condition? Okay, next, what is the flow or sequence of the each task? Okay, basically this one that whatever that I have mentioned here, this one you can obviously see when you develop the deliverables, the project deliverables like Gantt chart, right? So when you prepare the Gantt chart, so you have to know what is the deliverables, what is the milestone, what is the activity that you have to perform to meet each milestone. Okay, so the goal of the software process model here, okay, in order for you to meet all these milestones and in order for you to ensure that you have complete the requirements and you have delivered the end product, okay. So in here, the software process model is provided guidelines or can be provide a guidance, okay, for controlling and coordinating each task. How we can control, for example, the first day, okay, the first week, okay, the first activity that you want to involve is finding requirements, right? Remember in the assignment we have the requirement gathering techniques, right? Okay, so when you conduct the survey, let's say for example you have planned to conduct any survey or questionnaire, how long will you take? Are you going to take for 1 month for you to conduct the interview or questionnaire? If you utilize 1 month, what about the rest of the activities? When you going to finish it? Right? Okay? So that is the reason. So when you want to carry out any task, okay, you should know the timelines. Right? Okay, so when, where you have to complete this particular task. Okay, so in here the software process model is playing an important role, okay, which it consists of several phases. Okay, now here we have many kinds of okay, so the activities that to develop the software, as I told you, okay, here we have four main process, basic activities or process in software development. So the first one is the software specification. Okay, so software specification, software development, software validations, and software evaluation. Okay, so software specification, as I mentioned just now, so you need to find out the user requirements, the customer requirements, so what the customer needs, all that. Okay, then you start to develop the software, and then software validation. So once you have already developed, once you have already designed, coded all, so the validation is where the testing process. Okay, the testing process. And software evaluations here is, let's say if you want to do any modification, any modifications in future. Okay, because nowadays if you see all the systems or software that we develop is related to AI, right? Artificial intelligence. Okay, so those days, remember those days when we want to log in into any system, we only can use the username password, right? Those days. But now we using the AI, such as we have the finger recognitions, we have speech recognitions, and we have the fingerprint. So you can see we have implemented so much of AI, artificial intelligence, right? Isn't it? So this is what we call as the evaluations. Okay, evaluations which when the comes, okay, when the new trends or new things have been introduced, okay, so we follow that trend. Okay, so that is software evolution. Okay, now, so when I say software process model is which we say the software process, the roles, the product that you want to deliver, okay, and what is the perspective of different perspective here is based on the user. Okay, for example, like we are using the student intranet, right? So we have two student intranet and we have staff intranet. Okay, in point of student intranet, so you have your own requirements. In point of staff internet, I have my own requirements how the intranet, the system should be. Okay, can be used by myself. Okay, so now when we talk about the software process model, here we have many kinds of software process model, and like what I mentioned in a previous class, not all the software process model can be used for all the projects that assigned to you. Okay, the software process model can be considered based on project size. Okay, you can take note that. Okay, so the software process model you can consider when you want to based on the project size. Okay, consider the size of the project that you're going to working on. Okay, so the larger project means you have a bigger team. Okay, and you need more extensive and elaborate project management plans. Okay, other than project size, project complexity. Okay, so project complexity is where, let's say if the project okay, let's say that the project that you're going to work, sometimes you have the very clear user requirement. That means you can gather all the requirements from the customer clearly. That means the customer very clear, 100% very clear what they want to have in the system. Okay, some customer, they don't know. Okay, they don't know at all. Okay, when you ask, okay, what do you want the system to have, actually I have no idea. They have no idea what kind of system that they want you to build and what is the requirement. So they have zero requirements, zero knowledge. Okay, so there are several types of customers. Some, they are very clear. Okay, I want this. Okay, you do please. Okay, some, they are not very sure. Okay, maybe they need your advice. Okay, so once you give any suggestion, then only, oh yeah, I want this. Can you do for me? Can you see? So the customers like that. Okay, so that is the complexity, the project complexity. Okay, next is cost of delay. Okay, cost of delay here is the timeline. Is the timeline is flexible? Okay, so what is the project? What is the cost of the project? Is it a long duration or short duration? Is it a 1 year project or 3 months project? How much budget did you quote? Okay. Next is the customer involvement. Okay, as I told you just now, okay, some customer, they are very clear. Okay, so they just ask you to carry on, and later on you just have to show the follow up. Okay, some customer, they will be with you from A to Z until from the first day until you deliver the product to them. Okay, they will be together with you. Okay, so that is a customer involvement. Okay, next is a familiarity with the technology. Okay, in terms of the project domain, software tools, the language, the method they are going to use. So these are the aspects. Okay, so you can identify which software process model that you want to choose based on this aspect. Okay, so what are the aspects? Project size, project complexity, cost of delay, customer involvement, familiarity with technology. 5. Okay, 1, 2, 3, 4, 5. Okay, 5 elements. Based on these 5 elements, or based on these 5 criteria, so you can choose which is a suitable software process model which you can use it for this project, which assigned to you. Okay. Now, so if we look in here, okay, we have a few types of software process model. Okay, so the first one is a linear sequential model, or we can call it as a waterfall model. Okay, so waterfall model is a very short name. Okay, linear sequential model. Why they call it as a linear sequential model, I will let you know. Okay, the next one is the incremental model, spiral model, prototyping model, rapid application model, component based development model, and agile. Okay, Agile software development. Agile software developments, I think you guys are very familiar. Actually, we have several. Okay, we have several types of agile software development, but in here, I only focus on the XP and FDD. Okay? Okay. So when we talk about the software process model, we can split into two. One is a plan-driven model and plan-driven model, and we have an agile model. Plan-driven model is where all the requirements has been set clearly, okay, has been set clearly, and you just follow the flow. Agile is flexi. It's a flexi a bit, okay, which you can change the user requirements anytime. So it's flexi a bit. That's an agile. Okay, plan driven. You see the word also plan mean you have already planned initially what you want to do next and next. Okay, so if you want to do any changes, okay, you only have to wait until the end of the product. You understand or not? You cannot do any changes in the middle. That is a disadvantage. Okay, you can see in here. Okay, the what we call the comparison. This is a comparison table between the agile SDLC and traditional SDLC. Okay, so the comparison table, we can compare these two SDLC in terms of the adaptability, project size, planning, requirement, and risk. Okay, so let's say in your exam, if they ask you to compare, okay, if any compare, what we call or differentiate questions, okay, they ask, so you can do in this way. Okay, you can create a table, then you can list down all the features or the criteria, and then how you're going to compare. All right. Okay, so here, when you want to focus on the adaptability for the agile, as I told you, is a flexi. Okay, agile is flexi. Okay, and easy to adapt based on the customer needs and expectations. Okay, but traditional is a challenging to accept the changes, because you cannot do any last minute changes or any like on the spot changes, or cannot. So everything has been planned earlier. Must be planned earlier, and you have to follow the sequence. If in between any changes, you have to wait until you finish up the last stage. Then you have to go back again. It's a one loop, one big loop. Okay, so you can see in here. Okay, so this is the phases. This is the phases of the waterfall. Nowadays waterfall no more already. Okay, waterfall is called as a traditional methodology. It's a very old one. Very old. It's like something like a nene moyang already. Okay, it's very old. Okay, nowadays if you go and check with any software development companies, are you still using waterfall? They will ask you, what do you mean by waterfall methodology? Some of them they don't know also. This is very old version. Okay, now we have more advanced. Okay, but anyhow you should know. Okay, anyhow you must know what is the name of our name moyang. Okay, methodology. So waterfall methodology. Okay, traditional. Okay, so in here you can see, look at the arrow. Did you see any arrows is going back to the previous phase? Did you see any arrows are going back to the previous phase? No. Okay, so this is one of the drawback. Once you have finalized, okay, when you come to that particular phase, make sure that you have finished up that phase before you go to the next phase. You cannot U-turn back. If you want to U-turn back, you have to wait until the last stage. Then you can revise. That is make more time consuming, isn't it? Okay, let's say if you already code 20K, and suddenly something happened in the product, so you want to revise back everything. So from 20K, it will be over budget to 40K. Okay, so there are some limitations. Okay, there are some limitation of the waterfall methodology, and it's not being used nowadays. Okay. Okay, so here adaptability here. Project size, okay, as I told you, from the large to small scale of projects for the agile, and traditional you can use for all type of projects. Okay, planning, okay, for agile is pre-development process, and traditional the planning should be completed before the development start, before all the phases, so you have to plan well. Okay, in terms of the requirement for agile SDLC, it doesn't matter, it's not clear or not clear also doesn't matter, still you can work. Okay, let's say requirement here is the user requirements. As I told you just now, some user they are very clear what they want, some user they are not sure also what they want. So in this case, which SDLC that you can approach? Okay. So the traditional requirement must be clear. Requirement must be clear and won't change. It cannot change. Okay. Risk, unknown risk may be occur in any stage of software, because you know why? Because you keep changing the requirements, right? It's more flexy. The more flexy, the more challenges you will face. Okay, but in traditional, the risks are well known from the preparation, because you already know, okay, if I prepare this in this stage, so what are the possible risks which I face? So you know it earlier. Okay, so these are the differences between agile SDLC and traditional SDLC based on these 5 features. Any questions? Any questions, class? No. Alright, okay. So traditional SDLC is none other than waterfall model. Okay, in waterfall model we have a few phases. So which is we have a requirement. Okay, requirements where we will gather all the requirements from the user, and then we analyze, okay, based on the product model and business logic, and then design, coding, implementation, testing, operation and deployment, and last is maintenance. Okay, so this is the phases. Okay, you can go through. When can we use the waterfall model? Okay, when? Let's say if your requirement is fixed, it's not change. Okay, it's not change. And you have ample resources. And then you have the established timeline. And you well understood the technologies. And unlikely to require significant changes. Okay, if your project is got all these requirements, then you can think of using the waterfall model. Okay, so the advantages of waterfall model here is it will forces the structure and discipline organization, because as I told you, it's not flexi. Okay, it's come to the point. Okay, and simplify understanding and following the arranging tasks. Okay, and enable the early system design specification changes to be done easily, and it will clearly define the milestone and deadlines. Okay, the disadvantages here is because it's not design. Okay, design is not adaptive. Okay, when the flow is found, the entire process often needs to be started over. One loop you have to take. Again one loop. Okay, waterfall model delay testing until end of the development life cycle. Okay, waterfall is not ideal for complex or high risk ongoing projects. It's not suitable. Not working product is available until the later stage of the, so you cannot see any prototype. You cannot see any prototype model. You have to wait until you see the last part. You only can see the end product. You cannot see any prototype. Okay, that is about the waterfall. Okay, next is incremental. If you see the Mona Lisa, cute or not? Okay, incremental. Okay, when we talk about the incremental, okay, this is where you can see the model requirements are broken down into multiple standalone modules. Okay, in a software development cycle. Okay, so in here you can see just a very simple example that you can understand based on this diagram. Okay, if you see the build one, the first thing is requirement. Of course, okay, if you see all the software process model, the requirement is the first, because you need to gather the requirement from the user. The requirement, build one. Build one here is design and development. Okay, the build one, you can look at the Mona Lisa, the first number one picture. Okay, Mona Lisa number one picture. Okay, is referred to the build one. Okay, where you gather the requirement. After that, you do the design, development, testing, implementation. Done. Then build two. Build two, you can refer to the picture of Mona Lisa number 2. Okay, so the first half done. Now they continue the second half, right? Okay, so here again start from the requirement, design and development, testing, implementation. Okay, then build 3, build n, and so on is build 3, build 4, build 5, build 6. Okay, continuously. So build 3, again start with the requirement, design and development, testing, implementation, where you can see Mona Lisa number 3. You can see, so that means they will gradually increase. Okay, they will gradually develop the model part by part. Understand? Understand? First part, second part, and last third part. This is for the Mona Lisa. Okay, but our software, our system is not like that. We have a few models to be add together, right? Isn't it? So you will gradually. Okay. So for the incremental, each product is analyzed, designed, and implemented and tested gradually until the product is finished, until you deliver the end product. Okay, so in here you can see multiple development cycle taken place, right? You can see from the requirement, then design, development, testing and implementation. Okay, that is for the first round. Then second round again requirement, design, development. Okay, then third round again requirement. So can you see the multiple? Can you see or not? Okay, it's a multiple cycle taken place. Okay, and all this what we call cycles has been divided into smaller modules. Okay, which is you can see 1, 2, 3. Understand? So this is the incremental model. So in your assignment, let's say in your assignment, the system that you propose, if you want to gradually want to do one by one, okay, part by part, okay, so you can think of using this software process model. Okay, so the advantages here is generate working software quickly and early during the software life cycle, and the model is more flexible, okay, less costly to change the scope and requirement, because once you have done one part, then when you go to the second part, again you start with the requirement, right? So you can double, triple check with your customer. Because as you can see here, for each part, even though Mona Lisa is one whole part, when you want to do it that, so you do part by part. So every part you start from the beginning, which is the requirement, then design development, then requirement, design development, requirement, design development. So in here the requirement is not missed out here. So anytime you can gather the information or requirements or any modifications from the customer. You understand? Okay? Okay. It is easier to test and debug during, because now you're doing smaller part by part, right? So it's easy for you to find out any errors, any bugs. Okay, because you're just doing a smaller part, right? So it's easy for you to do the testing and you find the bugs. Okay? And in this model, customer can respond to each view. So the customer always be with you. Okay, the customer always be with you, and the way, and each time when you do, and when each time when you develop one part, so you can show up the follow. Okay, see, I'm doing this, I'm doing, are you okay? So you can follow up. So the customer also know what is going on there. You understand? Okay. Lower initial delivered costs, okay, easier to manage risk because risky pieces are identified and handled during the iteration. Okay, risky pieces mean any unknown errors or bugs. Okay, there are disadvantages, even though it's more flexi, but there are some disadvantages, which is need good planning and design. Because here on the spot you're doing, right? So you must have a good knowledge of design and also good knowledge in planning. Okay. Next is need a clear and complete definition of whole system before it can be broken down and built incrementally. Okay, for example, let's say if you plan to develop a login part first. Login part is the first part, right? The main entrance of the system. Okay, you need to develop the main entrance, which is the login. So in the login nowadays, you can see we have the forgot password, and then we have a new user. Okay, the retrieve password. So we have a lot of functions, right? Under the login itself, okay, the login page itself, you have a few sub modules that you have to come out, isn't it? Okay, new user, existing user, and then the down you have a few one which is forgot password or forgot username password, or whatever. Okay. Okay, when to use the incremental? So when you can use the incremental model? Okay, so this model can be used when the requirements of the complete system are clearly defined and understood. Okay, and major requirements must be defined. However, some details can be, so when the times come, then you can top up, but otherwise the main thing you should know earlier. Okay. There is a need to get a product to the market early. A new technology is being used. Okay, resources with a needed skill set are not available, and there are some high risk features and goals. Okay, so let's say if your project you have this kind of criteria, you can think of choosing the incremental model. Okay. Next is a spiral. Okay, spiral. Okay, spiral, very good. Okay, spiral is known as a cyclic model. Okay, using the spiral model, okay, the software is developed in a series of increments. So this is a kind of incremental release, but this is very headache one. Okay. It look like this. Even you can Google and see how the spiral is. Looks something like that. Okay, so it's more complicated. Yes, the shape is like spiral, the spiral shape. Okay, something like that. Okay, so spiral normally is used for the risk management, high risk management projects. Okay, high risk management projects. Okay. And used for large, expensive and very complicated project. It's not a very easy project or small project, very complicated projects. Okay, you can think of using the spiral. But don't worry, for your assignment, you no need to complicate yourself. So you no need to choose the complicated software process model, which is spiral. Okay, easy go. Okay, so in here, one of the advantage here is it can ability to build the prototype. Okay, you can see here when you can use the spiral model. Let's say the deliverables is required to be frequent, and you can use it for the large and complicated project, unclear and complex requirements. Okay, and the changes may be required at any time, large and high budget projects. So I keep telling you, okay, when you want to choose the software process model, so the 5 criteria that you need to consider, okay, the project scope, the project complexity, and other 3 stuff. Okay, very important. Okay, so example of the spiral model, um, like let's say your Excel. Okay, your Microsoft Excel, when you create the Microsoft Excel, what we call the small boxes, what we call that? Cell. Cell, right? CELL. Cell, right? Yes or no? Okay. Assume that is the first part. Okay, but this is actually I just given an example. Assume that you are developing this Microsoft Excel using the spiral software process model. Okay, so when you create the Excel, okay, when you create the cell, right? Okay, cell is a very important part, right? Look at Excel. So once we have already created the cell, so what are the things that you can create together with the cell? Other features or other applications that we can use. Join together. What can we do with the cell? Merge. Yes, merge. Okay, so the merge is one of the function, right? Okay, so okay, you just take this scenario. So when you started to coding the cell, started to create the coding for the cell, you already think that once I've already created the cell, so I can do the merge. So the merge function is automatically derived, isn't it? Once you started to code the coding for the cell, so the what we call the merge function has already. So you're also working on the merge function already. Okay, it's not that once you already created the cell, what you can do. Okay, so by the time you develop the cell, you already think, okay, I want to do the merge function inside. Other than that, what function that we can include? Other than merge. Merge cell, split cell. What other functions? Formula? Formula, right? Excel, we have formula, right? Yeah. Yes or no? Yeah. You guys using Excel for what?
Long time no use already. No.
Right, we have the formula, right? Okay, add sum, whatever, average, all that. So you can see, so once we started to think, once we started to develop the cell, we have all the other functions, okay, in our mind ready. Okay, we have to implement this, we have to implement this, we have to implement this. Okay, either we think of the organization or the the laws or the guidelines. Okay, so we have to approach that, we have to follow that. Okay, to implement. Okay, one more thing. For example, let's say you already almost developed. Okay, you already developed the software. Suddenly, the government say, okay, all the softwares are nowadays when you want to release so you should have this criteria. Oh my God, I'm going to release the software product. Now only the government asked to implement this. Because this system you want to use it in Malaysia, so you have to follow the Malaysian law, right? Okay, so the Malaysia law, they say, okay, all the software companies that they want to release the product, so all the product they should have these features. It's a compulsory. If not, they cancel the license. But you're going to deliver the product in 2 weeks' time. So it's a sudden, right? Isn't it? Okay, so which you have to implement. So you have to go back again. So this I say is a quite complex and risky. Okay, if you work quite complex and risky projects, okay, so you can think of using spiral. Okay, and spiral is, of course, because if the project is quite risk, of course the budget also will high budget. This cannot be a low budget projects because the complications are very high there. Okay, the risk of the project is very high. Okay. Okay, the advantages is high amount of risk analysis because you have to thoroughly have to do the analysis in and out. Okay, and useful for the large and mission critical project. Okay, this is well suitable for the government projects. Okay. Disadvantages can be costly model because as I told you, because of the scope of the project is very high and very risk project, so you have to spend quite some big amount of money. Okay. Risk analysis need higher particular expertise, so you should have a very knowledgeable person. Okay, must be a very knowledgeable person. Okay, and it definitely cannot work for the smaller project. Okay. Okay, the next one is a prototype. Prototype, yes, you can use it in your assignment also, you can use it a prototype. Okay, before you come into the real products, so you can have some prototyping. Okay. Okay, so when we talk about the prototype here, basically where and who will use it? Who will use it, the prototype?
The target users.
Is it the prototype will be used if the user know well about the requirement or they don't know anything about the requirements? They're not unclear about the requirements. You see the second point. A prototype is a toy implementation of the system. Toy, right? Toy. You just use it. After you break it, we can fix it back. They break it, we can fix it back. Okay? So it's called as a toy implementation of the system, not Toy Story. Okay? So now you tell me. Okay, this model works best in scenario where not all the project requirements are known in detail. That means it can be used, let's say, if the user unclear about the requirements. They are not sure. Doesn't mean that they don't know anything, but they know, but they are not very sure whether it can be used or we can use these features or not, or we can add these features or not. They are not very sure about that. So let's try. The try is a prototype. Try and see whether it works or not. It works, okay. It doesn't work, never mind. Okay, prototype. Okay, so you can see trial and error process. Okay, between the developers and user. You also not sure, it's okay, never mind, we build and see how strong. Okay, so in here the steps of prototype model, the first one is none other than requirements. Okay, requirement gathering and analysis, quick decision, build a prototype and do the assessment, and prototype refine, and then engineer product. Okay, so these are the 6 steps of prototype model. Okay. Okay, the advantages of prototype model is the customer can see the partial product. You know, when they build it, so they roughly know, oh, this is how my system is going to be look like. So partially they know, roughly they know, okay, how the system is going to be look. Okay, the early in the life cycle. And then this ensure the greater level of customer. Okay, because you are building this in front of the customer, right? So the customer know, okay, what is the, because let's say if you gather the requirements from the customer and then you do it and you show it, the customer wouldn't know, okay, how much suffer that you've gone through, okay, what is the difficulty that you've gone through, because they are somewhere and you are here. Okay, but in here, the customer beside you, they know what are the things that you're going through, what can and what cannot. Do you understand? Okay, what can be done in the system, what cannot be done in the system. So, because the customer is sitting beside you and they are watching what you're doing. Okay, so there is no for you to escape yourself, or there is no for them to pushing you, okay, you have to do that, because they are seeing that. So they should know what can or what cannot. Okay, so which one of the advantages you can make the customer satisfaction very high. Okay, and comfort. Okay. New requirements can be accommodated as there is a scope for the refinement. Let's say if there is chances for you to refine and you want to accommodate the new requirements, can flexi. Okay, missing functionality can be figured out. This is one of the advantages, right? Let's say if any function that you missed out when you do the prototyping, then you know, oh, this one I missed out already. Then you can do it again, refine. Okay. Errors can be detected much earlier compared to you build the entire product, then you do the testing, then you find the errors. You better find the errors in the early stage. Which one is better? A or B? Early stage or last stage? Early stage. Okay? The developed prototype can be reused by the developer for more complicated project in future. So they say they want to use it for the reference. Okay, can. Flexibility in design. So this is very called a very flexible software process model. Okay, even though it's too flexible, it does have some disadvantages. So what are the advantages? Okay, because it's too flexible, there are too much of variation of requirements. Okay, too much of variation of requirements. Okay, some more the customer sitting beside you, right? So much of things they will ask you to add this, you add this, you add this. Means auntie, shut up lah you. I'm doing this. Okay. So poor documentation because you cannot come out with one fixed requirement, because the requirements keep changing and changing and changing. So at the end you don't know what to come out with the report. Because so much of requirements has been changed, right? From A to Z. Okay? Poor documentation. It is very difficult for developers to accommodate all the changes demand. This is the customer. People are giving flexibilities also, they take more advantage. Okay? You understand or not? For example, you say, okay, this system only can be used in the bus. No, I want to use this system in the flight. Oh my God. This one only can be used in a normal mode lah. Cannot in the aeroplane mode. Cannot lah. No, I want the system to be used in a aeroplane also. It's too much like you. Okay, people are helping you, but your mode demand, right? Okay, you want an aeroplane mode lah, sleeping mode lah, whatever mode you have. Okay. This is okay, which one now? 1, 2, 3. Okay, determine the number of iterations be required. Okay. So the next one here is you can identify the number of iteration would be required before the prototype is finally accepted, okay, by the customer. Next is after seeing the early prototype, the customer sometimes demand the actual product to be delivered. Okay, because okay, I'm done. Okay, I'm going to finish it. Hey, can you deliver by next week? Please lah, I just start the first stage. You want me to deliver the product next week? Too much like you. Okay. Because the customers, they are so rushing and they eager. Okay, they want the system to be used very quickly. They want to use the system. Be patient. Okay, be patient. Okay, developers in a hurry to build prototype may end up with a suboptimal solution. Okay, the customer might lose interest in the product if she or he not satisfied with the initial prototype. Okay, so there are many disadvantages of prototype. Okay, so when can we use the prototype? Okay, this model is when the customer don't know. Okay, the exact product requirements. They don't know what they should add. Okay, they don't know. Okay, when the time that you build part by part, then only they roughly click in their mind. Oh, I wanted to add this. I wanted to add this. Okay. When the developer are new to the domain, For example, you are your first time, okay, your business woman or man first time going to launch a new system in market, but you don't know anything about that. Maybe education system, okay, but you're not from education background. You are from different maybe hospitality background, okay, but you want to launch an education system, which is totally two different background, right? Two different domain, right? So you don't know anything. So in that case, you can think of using the prototype. Oh, actually, the error, there's a spelling error there. When to use proto. Nobody noticed that. I myself noticed that. Okay, typo error. Never mind. Forgive me. Proto, which actually is prototype. Okay. Alright. Okay. Okay, so in this model, a prototype, I think this one, okay. Prototype of the end product is first developed, tested, and refined as per customer feedback, and it will be repeatedly do until the final accepted prototype is achieved. Okay, before developing the final product. Okay, so let's say if your project or your assignment got this criteria, then you can think of using the prototype model. Okay? Okay. Yes. When you talk about the prototype model, so we have under prototype models, we have a few 4 types of prototype models. Okay, so the 4 types of prototype models is what we call the rapid throwaway and evolutionary prototype, incremental prototype, and extreme prototype. Prototype, but under prototype we have 4 types of prototype. So when you want to choose prototype, so which type of prototype that you want to choose? Prototype is just one general term. Okay, but under prototype we have 4 types. Okay, which one you want to choose? Okay, so the first one is throw away, or we can call it as the rapid. Okay, rapid prototype. Okay, when we can use that? Okay, rapid prototype, or we can call it as a close-ended prototype. Okay, rapid or close-ended prototyping. Okay, so this type of prototype, okay, is used very little effort with minimum requirements analysis. Okay, to build little effort with minimum requirements analysis. Okay, let's say once the actual requirements have been understood, for example, roughly, okay, I'm the customer, okay, and you are the developer, so you're using the prototype. Okay, so you show me the first part. Okay, the first initial prototype you have done ready. Okay, then from there I can capture, okay, what actually I want. I know already. From the basic, I don't know anything. Now I know at least 50% of the requirements what I want. Right? From 0, now I know at least 50%. Okay, what actually I want. Then I started to give you the feedback. Oh, okay, I know already what I want. Okay, can you add this? Can you add this? Can you add this? Understand or not? From 0, now you know, what you want the system to have. Okay, so that is called as a rapid prototype. Once you know the requirements, then you quickly can do the rest. Prototype, why we do? Because we don't know what actually we want, right? Then we try error. But once we know exact, this is what we want, then we can carry on already. We can done already. Okay, so that is rapid prototype. Okay, clear, understanding, and user requirements. Once we know, then carry on. No more prototyping. Stop that, and then you can do the real ones. Okay. Next is the evolutionary prototype. Okay, this is what I told you is based on the trend. Okay, initially maybe 6 months before. 6 months before, Okay, I plan, okay, I want the login system, use the username password. Okay, but after 6 months or after a few months later, I found out that other software companies, they are not using the username password. They are using the biometric. Okay, they are using the biometric like iRetina, or they use the thumbprint, or they use the speech recognitions, or they're using the biometric. And then suddenly strike in your mind, it can be tried that. Understand or not? Initially you played username password. It's a very normal way, right? To access. But now we try the biometric. It's more safe, right? Because username password, anybody see, if I know your username, I can easily get into your system. But biometric, even though you are twins, it's not necessary that you are, even though you are unidentical twins also, it's not necessary your fingerprint must be same. Okay, so why don't we try that? Latest trend, latest technology, or we use AI. You understand or not? So that is called as the evolutionary prototype. Okay, we prototype the thing based on the latest technologies or latest trend, or what are the latest practice. Okay. Next is the incremental prototype. Okay, incremental prototype is where it's referred to the multiple function prototype with a various subsystem. You have a subsystem. Example like we can take the bank ATM. Okay, we can take the bank ATM machine. Okay, so where you need to insert the card first. After that, you will do the verifications of the card, and then only it allow you to enter the PIN number. Okay, then you can do all the transaction. Either you have to do whatever things. Okay, so you can see the modules, the sub modules. Okay, the sub modules over there. Okay, so this is also we call as an incremental prototyping. Okay, the last one, extreme prototyping. Extreme prototyping, we can use it when we want to develop a website. Extreme prototype, when we can use it if we want to develop a website. Okay, you can think of using extreme prototype. Okay, so you can see the differences between all these four prototypes. Okay, so this is the explanations about this. So you can see the extreme prototype is mostly used for the web development. Okay, so you can go through the explanations. Okay, the next one is the RAD model, which is called as a rapid application developments. Have you heard about this RAD? When can we use? RAD can be used if the user knows the requirement or not clear about the requirements. Clear or unclear requirements? Unclear requirements. Or you're not sure? You nodded your head like this, mean what? You don't know or unclear?
Unclear.
Unclear. Okay, so it's without any specific planning. Okay, we can use it. Okay, normally RAD people use it if they want to develop any apps. Mobile apps, you know, right? Okay, so when you plan to develop any apps, okay, you can think of using the RAD. Okay, rapid application development. Why? Because you can see here, so it's a software development and user that can produce a better feedback when they examining the live system. Okay, so in here you can see several phases. Okay, this phase you can use it. Okay, very shortcut. Okay, actually already as a shortcut methodology, rapid, very fast. Okay, very fast compared to prototype and incremental. Okay. So you can see here as usual requirement, okay, requirement planning, okay, and wait a minute, okay, and then here you have the prototype, the user design prototype, then you test and you refine back, very fast, okay, this one very fast it can be done. For example, let's say if the prototype and incremental is take around 2 weeks, not 2 weeks, maybe 20 days or 1 month. So this is just take 10 days or 15 days, half of it. Very fast you can do this. You can use this prototype. Very fast response. Quick. The word also you can see rapid. Okay. So very fast you can come out with a prototype, very fast you can conduct the test, very fast you can do the refine, and very fast you can do the constructions and you have the cut over. Okay. So for the RAD, okay, so these are the phases of RAD. Okay. Actually we have 1, 2, 3, 4, 5. Okay, 5 phases. Okay, business modeling. Okay. So business modeling is called under the requirement planning, okay, where the information has been identified, the requirements has been identified. Okay. After that we have the data modeling and also the process modeling. So the data modeling and process modeling, all that is where the prototyping, the test, refine will take place. Okay. Then the next one is the constructions. Okay, so the actual system is built and coding, okay, using the automation tools. Remember tools we have the semi and automated. Okay, we have our automation tools to convert the process and the data models. And then last is we have the testing and turnover. Okay, testing and turnover. Okay, so these are the things. So the advantage of RAD is more flexible for change, any requirements. In this model, changes are adaptable. And then each phase in RAD brings highest priority functionality to the customer. And it can reduce the development time. Okay, as I told you, from 30 days, it can reduce to 15 days. Half of it you can cut. Okay. And it can increase the reusability of features. Reusability of features here is, for example, something like a recycle. Okay, recycle features. Recycle features mean, let's say in a home page or in a system A. Okay, in a system A, you have added all the login, all those functions. So when you want to enhance the system B, you can recycle back the same features. So which in system B also you can use the same login, so you no need to modify anything. That is called recycle or reusable. You can use it back. You understand? Even though system A is developed by other developers, system B is developed by you, but you can use it back all the features in the system A. You can use it back. You can coding back. So that is what we call recycle or reusable. You understand? Okay, reusable features or recycle features. Okay? Okay, disadvantages is require high skill designer. Okay? Because everything we have to do very fast, right? So you can have the fresh grad to come and do here, cannot. Okay, you must have the experienced people. Okay? And all application is not compatible with RAD. Okay, and you cannot use the RAD for the smaller projects. Okay, and one on the high technical risk is not suitable. It's not as suitable for the technical related projects. Okay, and it requires the user involvement. Okay. So when we can use the RAD, you can see here, when the system should create this modularization in a short span time, as I told you. half of the time, half of the month you have to cut out, 2 to 3 months. Okay, when the requirements are well known, if you want to use the rapid, you should know when the technical risk is limited, when there is a necessity to make any systems, okay, with the moderation of 2 or 3 months of period, and it should be used only if the budget allow the use of automated coding generated tools. Okay, that's why I'm telling this is most suitable for the apps, okay, mobile apps. Okay, next, component based development model, okay, or CBD. Okay, so you can see in here previous with CBD. What is the difference that you can see? The previous system and the system with the CBD. What do you see? What is the difference? What is the difference that you can see with the previous and big CBD? Without CBD and big CBD.
Recognition. Meaningful icon.
Oh my God! Can't you see any difference? I'm not minimizing the screen. Okay. So what is the obvious difference that you can see? The clear difference that you can see here. Only size. I told you that I didn't maximize or minimize the screen. Look at the icon. Look at the icon there. With the previous, you can see the printer icon and the letter, right? The letter icon, whatever icon, okay? You can see it's not in the symbol base, right? Symbol base, but it's not very clear, isn't it? But in here, you can see with the CBD, everything has been symbolized, okay? You can see the Twitter, Facebook, Instagram, IN, or link. Okay, and then you have the mail, printer, and then you have the download copy or save as, whatever. Okay, you can see the icon, the component. The component here, okay, the component basis, this is what we call the component base. Okay, each of the components. Okay, how we can reuse the components. Okay, how we can reuse the components. Okay, but this one is just for your knowledge, we're not going to use it. Okay, next, agile. Okay, just now we talk about the traditionals, or then now it's agile. Okay, so agile is an approach to the software development, okay, which is seek the continuous delivery of working software created in a rapid iteration. Okay, so nowadays, even though agile has been using by most of the software developers companies, but agile also got some disadvantages. Okay, so let's look at the advantages first. Okay, the main advantages is customer satisfaction. Yes, because it's flexi. Due to the flexibility, okay, the customers are very happy because anytime they can change the requirements. Okay, and they can check the software release and review the feedback. Okay, and then in agile process, mostly the meeting arranged before the product released. Okay, and most of the interactions maintained between the developing and testing team in the agile process. So that's why they're focusing more importance, or giving importance on the testing. Okay, and here one more thing, customer can change and add requirements, and even though tomorrow you're going to deliver the product, you already done your testing A to Z. You have done your unit testing, integration testing, system testing, whatever testing, everything done ready. Done. But suddenly your customer says, can you add this function? Oh my God, I done all the testing. It's okay, you add. You see? So that is because it cannot be over flexi. This is the consequences if we be over flexi. Okay, there are some consequences if you be over flexi, there are some consequences if you are very strict. Okay, and it's concentrate on every process with expert team members. Okay, the disadvantages is of course lah, because you're over flexi, of course your document also very lengthy. Okay, and it's not useful for, of course, okay, agile is not useful for small projects. If your project you want to deliver in a 2 months time or 1 month time, don't think of using agile. It's not suitable. Okay, and it's required the expert person to take important decision in meeting. Okay, and its cost is more compared to waterfall interactive models. Okay. Interactive models like what I say just now, the prototypes, all that is called the interactive spiral, all that. Okay. So as I told you, agile we have many agile methodologies, but we're only going to focus 2. Okay, from that, which is the XP, not Windows XP. This is extreme programming. Okay, extreme programming. I'm so tired already. Okay, extreme programming, XP. Okay, anyone have heard about this XP? Anyone knows about XP? Would like to share some information about XP? Not Windows XP. Who's that? Who's that? Nowadays Windows XP also not in use, right? What is the latest OS? What is the latest OS? Windows 11 Got man?
Windows 12
Is it myself outdated? Alright, okay, now. Okay, XP is one of the most important software development framework in agile model. Okay, and it's mainly used to improve, of course, all the models are using to improve the software quality. Okay, and then responsive to the customer requirements. Okay, so in XP you can see here. Okay, this is the way. You can see how the model, XP model. Is there anyone that can understand? Can anyone understand?
Yes.
Okay, never mind. I will tell you what are the phases. What are the phases involved in XP? Okay. The first, XP models. Okay, the first thing is they have the requirements as usual. Okay, they do have the requirements here. Okay. Okay. Then after that is they have the iterations. Okay, before the release planning. Okay, so they have the iterations. Okay, before they have to release, they should get the customer approval. You can see there's one more thing, customer approval, before you release the product. Okay, so here they have a several. Okay, they will conduct a several types of testing. Okay, which is a unit testing, integration testing, system testing, and UAT. UAT also they have the beta testing, alpha testing. So there is one particular topic where we will focus on the testing. Okay, testing also we have so much of testing, so many types of testing. Okay, we talk about that. Okay, so in here you can see the code reviews. Okay, so I just roughly tell you. Okay, so the code review is one of the important phase when. Okay, so the code review will help you to detect and correct the errors. Code review. Okay, you can see here. Okay, but I'll tell you what one of the requirements, one of the phases. After the testing, as I told you, is testing. Okay, the testing they do because they want to remove the errors and they want to improve the reliability of the system. Okay, after that they have the incremental developments. Okay, incremental developments is based on the customer feedback. Customer feedback. Okay, after the each iteration, so you can see here the iterations. So can you see the looping here, each iterations, okay? After they get the customer feedback for every testing, so they modify here, okay? And then they have the simplicity. I didn't bring my umbrella.
Finished today.
I left my umbrella in the car. I thought it won't rain. Okay, then design. Okay, design is the good quality of design is important for the develop the quality, software quality attributes. And then the next one is integration testing. So in here you can see we have the testing. The testing is the acceptance test. Acceptance test is one of the testing. Okay, which we carry out in the extreme programming. Okay, they will do a lot of testing in the extreme programming. Okay. So the advantages of XP here is simple code. Okay, you can do a very simple code and you can improve the code. Okay, and the whole cycle of XP is visible. You can see it's nothing. It's not a hidden. There is no hidden phases. All the phases you can see. Okay, and constant testing make the process more agile and uplifting the talent of teams. Okay, the disadvantages here is they are giving more attention to the code, okay, because they want to do the testing, right? So the coding only they are giving more importance, but less important to the design. Okay, less important to the design, more importance to the coding and testing. Okay, not working in remote working teams. Cannot work in remote working teams. Okay. If issues are not documented rightly, possibility for repeating the same issues are very high. Okay, whatever issues that facing, okay, everything you have to document. Okay, so that is the disadvantages. Okay, the next one is the FDD, okay, which is feature driven development. Okay, FDD. So FDD also one of the agile methodology, yeah. Okay, agile methodology family. Okay. Okay. So in here you can see we have 5 phases, steps. Okay. The first step here is to develop an overall model. Okay, so in this step, this is the first step of FDD where you need to outline. Okay, you need to outline the initial domain object model. Okay, so where example like the future user customer company, okay, you can the teams of the developers. Okay, normally the teams of the developers and the domain expert will sit together. Okay, they will sit together. Okay, then they will review the models. Okay, they review the initial model. So that is the first step. Okay, the second one is develop the feature list. Okay, so once they have already come out with the initial reviews, okay, of the models, okay, then they will come out with the features list. Okay, the features list such as the functionalities, all the functionalities, okay, in the system, what function you should have. Okay, build the features list. Okay, that is the second step. Okay, the third one is plan by feature. Okay, so even though, okay, for example, you have already come out all the features. Okay, this system should have login, this system should have the customer support, this system should have the email, this system should have the make payment, all that you already listed. Already listed, okay, which is you have done it in a second phase. In the third phase, plan by features mean you have to, from the 7 features that you have mentioned, which is the most important features urgently need or must be do first. From the 7 features that you have mentioned, you listed, which is the most critical features, most important features that you have to build in the system. What is the most important features? Plan by features is that. Okay, in that phase you will sort. Okay, you will choose which is the most important features, which one that you have to build first, which one you have to build second, third, fourth, and so on. Very urgently have to meet, okay, have to build based on the user requirements. Okay, so that is plan by feature. Okay, so for example, which feature the customer need very urgent, which feature do we have to be delivered very soon. Okay, so all that. Okay, which feature is got a dependency or independent, okay, features. So everything you have to find out and you have to act accordingly. Okay, that is we do in a plan by feature. Okay, the next one is a design by feature. Then the next phase, okay, phase 4. Yeah. Okay, so phase 4 is a design by features, which you can see is come with the modules. Okay, the sub modules. Okay, and then you started to build the features. Okay, build by features, plan by features, design by features, and build by features. So in here you can see the word feature, right? Feature. That's why you can see the model also feature driven development. Driven development, so FDD. Okay. So the advantages is clear picture of the project scope. Okay, that means the customer should have the clear picture. It's a user-centric approach, and it works good with a long project. And if you want to use the FDD, make sure that you cannot use this one is you cannot use in a single developer. Single developer cannot use the FDD. It must have many developers in a team. Many developers in a team. Okay, it cannot build by the single developer. Okay, decreased need of meetings. Okay, disadvantages doesn't work good with the small projects. Okay, and depends on the lead developers, and no written documentation to the client. No documentation will be produced. Okay, so this is the disadvantages. Okay, so guys, in your assignment for the software process model, okay, buyer should know, okay, based on your requirement spec, okay, all those stuff, you should know which software process models can be used. Okay, understand? Don't choose waterfall. Don't choose waterfall, okay, don't put yourself in very the boil soup. Okay, so think of choosing, and don't choose the spiral also. Okay, so class, when you do your assignment, because you're not going to have any field work here, so everything is based on your own justifications, your own findings. Okay, so when you want to propose this software process model, then you need to justify with the relevant findings. Okay, with the relevant findings. Why did you choose that software process model? Why this software process model is suitable for your LMS? Okay, don't put one sentence simply. Okay, I follow my friend, then knock your head. Okay, so I need the proper justification and proper proof, evidence, and also findings. Understand? Understand? You got my point? Alright, okay. So this is the exercise which you can go through. You can go through and try to do it, but we're not going to discuss, just for your own practice. Okay, but anyhow, for the tutorial, okay, for the those who have already which group that have already discussed the tutorial 1, so you can start do your tutorial 2. Now it seems they already complete the chapter 2, so by then you should know how to answer the tutorial 2. Okay, do it as a homework. Okay, any questions? No, okay, is there anybody bring umbrella?